Okay, carrying on with potential divider circuits. Thermistor and LDR is in a potential divider circuit. Thermistor is an LDR, so thermistor is something that reacts with temperature. It should be pretty straightforward from the word there, therm. LDR, remember, is light dependent resistor. Okay, so it's a resistor that changes with light. So remember the symbol for the thermistor essentially is a resistor with a temperature symbol across it. LDR reacts to light, so draw some light going onto the resistor. What is the variable? Remember, this one was temp, this one is light intensity. If variable increases, so in other words, if temperature increases, the resistance will decrease. If the light intensity increases, then the resistance will decrease. So using a potential divider circuit, so here we have a thermistor put into this potential divider circuit. So in this case here, what's going to happen as, let's say we had resistance R, resistance thermistor, we had EMF, and we had an output voltage. In this case we've rearranged it. Call that circuit 1, call that circuit 2. Now in circuit 1, you need to write this in full for your notes. But essentially, if the temperature is going to increase, then resistance of thermistor will decrease, and that means the voltage output would increase. And if you think about it, if that was 10 volts there, and we shared it amongst these two resistors, and this resistor stays the same, then the ratio of the two resistors will depend on how this one changes. If this one changes by going down in its resistance, it's going to have a smaller ratio. In other words, let's say we put some values in. Let's say when this thing is at 50 degrees, it's 10 ohms. And this is 5 ohms. Okay, then the output voltage will be 5/15 of the total EMF. Okay. Now, as the temperature increases, the resistance goes down. So let's say instead of 10, it went down to let's say 1 ohm. Then the output voltage will now be 5/6 of the EMF. So we went from 5/15 to 5/6, and you can see that the ratio is increasing, so it's taking a larger share of the EMF. However, this one here, circuit number 2, is actually opposite, okay, because the resistor is now down there. So if the temperature increased and the resistance then decreases, that output voltage will actually decrease. Okay, so you need to explain all this in words. Essentially just like I did with these diagrams, but in a longer way. And the same thing happens with the LDR. So if we had EMF, a resistor, and we'll call it L, and a resistor 1, and an output voltage. Then the same thing, the ratio of these two will determine the output voltage. So remember, it's EMF multiplied by your ratio, and that will give you your output voltage. So depending on your ratio of resistors, will tell you how big your output voltage is. And if the resistance of that one goes down, well then your output voltage will increase, because R1 over R1 plus RL, in this equation here, if RL goes down, then the bottom line gets smaller and that means the ratio gets larger, so the output voltage is larger. And if you look at this one here, it's the opposite way around because RL is now on the top, and so if we lower, oh sorry, that should be 1 there. If we lower this one down here, then the output voltage will also lower instead of it rising in that case. So if we lower the top line, then the fraction is actually going to get smaller, okay, faster. So here's an example you can do. Let's have hot and cold, and so the resistance of the thermistor when it's hot is going to be 600 ohms, and the resistance of the thermistor when it's cold, well, here's a question for you, is it lower or higher? Good, I hope you got that right. So when it's cold, let's say we make it 1200 ohms. Okay, what's the resistance of this resistor here? Let's make it 800 ohms. Okay, what we're trying to measure, we want to know the voltage out. We have EMF in, so I want to know what is the voltage hot and what is the voltage cold. Okay, the potential difference when it's hot, potential difference when it's cold. And you also need the EMF, which is 10 volts. Okay, this example, let's put in a resistance here of 200 ohms. Okay, EMF, let's give it an EMF of 6 volts. Okay, I want an output voltage of at bright, I want 1 volt, and at dark I want 5.5 volts. So now you need to solve. I want to know the resistor range for the LDR. Okay, so what is bright and what is dark in terms of its resistance?